Hey Garrett,
Hey,
um, I've gotten a few emails on questions to answer, so I'm just writing down all of the numbers to make sure that I cover them all. So I'm gonna switch over in just a second. Um, Hang on. I got a lot on the quiz that's on page 179, and then I have some from textbook and that kind of thing. But I haven't gotten any on the worksheet from Mrs. Wynn's class. Um, I may start. I've gotten a few from the textbook. We had some textbook work in my class from lesson 3.2, which would cover some of the concepts that are in the quiz. And then so far, I've gotten emails about numbers. Hang on just 1 second. I'm double checking one additional email that I got. Um, okay. I got questions actually 8 through 15 for the quiz, and then I've got a few from the textbook. So I'll just start with the textbook problems, which there was only 3 that I got over that, and then I'll just move straight into the quiz and go from there.
this Sparks.
Yes.
Raining kind of hard. Is that annoying to you guys? Can you hear it?
What? I can't.
It's
I'm
like,
not hearing.
okay, because it's really loud for me.
What is it? What's the
Pouring.
noise?
It's pouring rain, and I have like skylights, and it's making a really loud noise in the room I'm in.
Oh, bless your heart. I can't hear it at all. I don't
Okay,
know
cool.
about the other students. Um, but I can't hear it at all. So but I'm going to start with number 50, and I don't remember exactly what the page number was. Um but here's what the problem looks like.
I needed help with page 179, 12 through 15.
Okay. All right. I have that written down. And then I also had another student email me about numbers 8, 10, and 11. So I'll be covering quite a few of them from the quiz on page 179. But I've
Okay.
got 3 additional problems. I didn't get any from Miss Wynn's class on the worksheet because I know she handed out an additional worksheet for quiz review. I
I
didn't
read
get
out.
any emails about that. But I'm going to start with number 50 from the textbook. On a previous lesson, it's 3.2. And the problem looks like this. I'm trying to read my own handwriting. I'm sorry, guys. That's pitiful.
Wait, are you sharing your screen?
Oh, no, thank you. Bless your heart. I appreciate you speaking up. I guess I'm not. I should be, though.
I only see your icon. Okay, now I see it.
Thank you very much for reminding me. There's a couple things that I have to do to make that happen. So, um, if I'm writing everything, oh my. Okay. This is what the original problem looks like. So what you would want to do is, because I'm going to go ahead and take my x's and make those into fractional exponents, because that looks like the easiest way to combine those. There's a number of things that you could do. This is just the method that I would use. And I can simplify my denominator, praise the Lord. So for the numerator, I'm going to combine 1/3 and 5/2. And that's going to look like this. I got to get a common denominator, which is 6. 3 goes into 6 2 times. 2 times 1 is 2. 2 goes into 6 3 times. And 3 times 5 is 15. So that gives me 17 over 6, 5x to the 4th.
Miss Sparks?
Yes.
Is there any way you could do it like where you simplify the like other the numerator, you take the x's out of the radical sign? Like, is there any way you don't do it with fractions?
I'm sure that there is, but the reason why I did it that way is because my roots weren't the same.
Okay.
And so that's why I defaulted to that method. But we could actually try to work on that one a little differently.
And how did you know, like, for the x to the 5th under the square root sign, how did you know to do 5 over 2? Like, that confused me.
Oh yeah, me too.
Oh, okay. Well, because what's inside here is the denominator always. So 2 or 3 or the 4th root or whatever, that's always the denominator of the fraction. And what it's raised to, or the power, is the numerator.
Okay. That makes sense.
Okay.
Okay.
So I'm sitting here trying to think. Oh, and I did this wrong too. I took the square root of 16 as opposed to the halving it. And when I was looking back over my work to
Miss Sparks, are you going to post the answers to these questions?
Yes.
Okay, that'll be helpful.
For 3.2 or for the quiz also?
For both of them.
Okay, and I've really not left myself a lot of room, and I have an entire page of work for this problem. Not that that makes y'all happy, but I do. So I have and then I can take 2 x's out, 2 sets, because 6 goes into 17 2 times, and it leaves me 5. So I don't know if you got something kind of close to this, Rachel, by doing it the other way. The other way, did you?
Let me look. Not really, no. I did not know how to do this one.
Okay. And then I hate to do this. Does everybody have the work up here? Because I'm going to have to erase this because I just wrote too big, not even realizing. I don't know why I did this because I'm like, I literally have half a page of work on this one. So I didn't leave myself very much room, and I'm really sorry. Okay, so I'm going from x squared times the square, or the sixth root. This should have been a 6 in here. Sixth root of x to the 5th over 5x to the 8th. And now what I'm going to do is combine my 2 and my 8. And I'm praising God at this point, and you'll see why in a minute. All over 5, because I took this and subtracted that from it. And that's going to give me a -6, which just means that that's going to end up in the denominator. Like that. And that's my final answer. As ugly as it is, that is my final answer. And I promise there won't be anything that hard on the quiz. I promise. Once again, some of these are just kind of to stretch us a little bit on the classwork.
49.
Yes, I could do number 49. Did you get that written down, Rachel?
I did, yeah, I understand.
Okay. I can go back and do number 49, but I also have 54 and 59 down as questions asked.
Okay.
And I do want to leave myself plenty of time to go over the quiz. But I can do 59 or 49, I'm sorry. But I do have 59 written down also. Did somebody say 49, or did I hear that correctly?
Yes, ma'am.
Okay. This reignites y'all's love of fractions, doesn't it?
Yeah.
Okay, 49. So it is the cubed root of x squared times the 6th root, nice, of x to the 4th, all raised to the -3 power. Let's see if I can write a little smaller this time. Okay, so the -3 tells me it's all going to go to the denominator, and nothing could excite us more than having radicals in the denominator, because then we know we get to rationalize them. And we know they're all fractions. So I got rid of the negative. And now the next thing that I'm going to do is go ahead and convert my radicands into rational exponents. And I'm going to speak this out loud because this was the part that kind of threw you guys off just a minute ago. The denominator is what's in the radical part over here. And the numerator is the power for which it is raised to. So the denominator is what's in this little check mark part of the radicand, if you will. And the numerator is the power to which it is raised to.
Okay.
And then all of that was cubed. And basically, that's 1. That reduces to 2/3 as well, right? No. Yeah. All raised to the 3rd power. You can do this a number of ways, but I'm just going to do this. And that's your final answer.
Okay.
All right.
So
and then I'm going to...
the like where it says 4/3 and then like to the 3rd power, the 3's just cancel out and it's just x to the 4th.
Yes, ma'am.
Okay, that makes sense. Thank you.
Oh, you're no problem. Great questions. And always ask questions for clarification. So we've done 49 and we've done 50. I'm going to move to 54. And I'm going to see if I can plan my white space a little bit better and see how much work I have for number 54. Oh, and it's interesting. Being the geek that I am, I actually worked number 50 twice, and I did do it a little differently, but I did take it to, I didn't leave it in the radicans either time. I've done fractions both times, but I did it differently another time. So I can show you guys that tomorrow if you want to see it, Rachel.
Okay.
But it's just one of those things where, like I said in class yesterday, there are multiple ways of, you know, kind of attacking these problems. Just as long as you're following the, you know, the radical and the exponent rules, you know, you can approach it differently.
Okay. Can you like take the things out of under the radical? Because that's what I was trying to do.
On this one?
Yeah. Like you could take like 1x out of the radical, and then you have an x left, and then you can take 2y's. See what I'm saying?
Yes, I think I do. I just want to make sure I write the problem down right first.
Okay, go ahead.
And I think I did that. As a matter of fact, I think probably your least favorite thing that I do in class, the students like the least, is I think I wrote everything into factors. On this one is what I did on my paper.
That's what I did too. I actually like that way better.
Is it?
Yes.
Oh, okay. All right. All right. Because that is what I have down here is the cube root of 2 times 2 times x times x times x. And then I think I didn't do all the x's out. I was lazy. Because on that one, I just kind of like look at my exponents and see what I can pull out. But as far as like the number or the constant, I actually write that into factors. So 2 times 2 times 3, and then y squared. So now what I do is I rewrote everything underneath the radical together. So, but you pulled it out into each one. Is that what you did, Rachel? Because
Yeah.
I actually then rewrote the whole thing like this: 2 times 2 times 2 times 2 times 3. And then I have x cubed, and then I have y to the 7th.
Okay. Is there any way you could show me it when you do them separately?
Sure.
Okay.
So over here, I was able to take out an x, and I was able to take out one y. And underneath the radical would have been left 2 times 2, and then a y squared. And then over here, wasn't really able to take anything out, right?
Right.
But when I combine everything under the radicand, I have 2 times 2 times 2 times 2 times 3. And then I'm able to combine y to the 4th. Or no, this should have been, yeah. Oh, yeah, y to the 4th. Right?
Right.
So I'm able to take a 2 out. And I'm able to take another y out. So that makes that y squared. And that leaves 6y underneath the radicand. And that's my final answer.
Okay, I see how you do that. So you're allowed to combine those things under the radicals?
Yes, ma'am.
Okay, but only if they have like the same to the degree, like if they both have like that 3 there, right?
Yes, I'm sorry. And I didn't write it in my final answer. My apologies. Yes, yes. Good point. Very good point. That would be like if they had the same denominator when they're rational exponents. But yes,
Okay.
that's the only way that you can combine them. I'm glad you brought that out. Okay, so that was number 54. And now I'm going to do 59. Okay, so to actually simplify this one, what we need to do is rationalize the denominator. So what we want to do is how many more x's to the 7th root would we need to get the denominator to be just an x? Like how many more x's do we need to pull that x out?
2. Or
Correct.
okay.
So the 7th root of x squared over the 7th root to x squared. So now that makes our numerator look ugly, which I'm aware, but we'll get that fixed. And I'm going to be real honest with you. I think in my original way that I did this, did you happen to switch this to fractions or did you keep it in the radical?
No, what I did was I tried to take everything out, but that didn't really work. Like the numerator, I tried to take some of the x's out, and so then you had like something weird.
Okay, so you basically had x, and then you had the fourth root of x squared?
Yes.
Okay. All right.
Like, is it allowed to do that, or should you just go straight to doing this?
I would probably go straight to doing this just to kind of keep things uniform. But I also, to be honest with you, would have probably rather to do this in fractions. But it's kind of like fractions and decimals. I like fractions better than I do decimals, and I actually like fractions better than I do radicals. So a lot of times I go ahead and switch my expressions, but I want to kind of be able to show you guys both ways. Does that make sense? So, and then, so I don't want to force how I think on you guys, but you're going to have to go to fractions at some point on this one anyway, because you really can't, just like before when you ask, as long as it's the cube root and all of that, you can combine what's under the radicand. You asked that just a few minutes ago, and I said, yes, good point. Well, we're going to illustrate that here in just a minute.
Okay.
So now we've got a seventh root of x to the seventh. Praise the Lord. Our denominator looks okay, but our numerator is ugly.
Can you take out that x now in the denominator?
In the denominator, yes. But what I'm going to do at the top is actually, this is going to become this. And at the bottom, we've got just that.
Okay.
And I'm starting to write big again, which isn't good. So I have to, I'm going to actually reduce this to 3/2, just because I don't want my common denominator to be so big. So now I have x because in order to add those exponents, I have to have a common denominator. Right. So 2 goes into 14 7 times. 7 times 3 is 21. 7 goes into 14 2 times. 2 times 2 is 4. So that gives me x over, oops, sorry about that, 25 to the 14 over x. And this was a 1. So technically, that is 14 over 14. So my final answer, 25 minus 14, my final answer is x to the 11 over 14, which can be written that way, or it can be written like this. All right. I'm going to start erasing some of this. I'm not going to erase the bottom part in case you're still writing.
No, I'm good. Thank you.
Uh-huh. And then I'm going to move on to the quiz. I'm assuming the first part must have been pretty easy because I didn't get any questions on it till the second part. So I guess that's good, right? So y'all feel good about the first half. Praise the Lord. Because there are definitely a lot of moving pieces and parts to radicals and rational exponents. That's for sure. And just make sure you guys are, taking your time, pay attention to detail on these. All right. And I got to make sure I get my book pulled up on the other computer because I want to make sure I write them all down right.
What page is this?
This is the quiz on page 179.
Okay.
Let me make sure that you all see exactly what I'm doing. I'll pull the book up for just a brief second so that y'all can kind of see that. But with regard to emails that came in, the first one that I was asked about, I mean, the was number 8 on the quiz. So if there's one before that and somebody's come on to Math Lab for that, please let me know.
I came through 12.
Okay. All right. I'm definitely going to hit those. But I also had questions about, I think it was 8 and 10. So I want to make sure that I'm hitting those too. So I'm going to start there. Number 8. Yay. Was x plus 3 equals. And these weren't so bad because technically, and I'm going to, oops, I'm sorry, guys. My calculator is broken, so I may have to, I don't know if my phone calculator, if I turn it sideways, will do this or not. But x plus 3, oh, that was cubed. So I'm going to take the cubed root of both sides. So that gets this out of the radicand. And if I do the cube root of negative 16, like I say, let me turn my phone sideways and see if I can do it. Because on these, you were just asked to do it with a calculator. So let's see. Negative 16 and then the cube root. So I get negative 2.519. Actually, I'm just going to go with 5.20 myself person. Well, and then I'm going to subtract 3 from it. Because when I round this, so that gives me x equals negative 5.52. And that's the answer.
Okay, that makes sense.
Okay, good. All right, so that was number, I believe that was number 8. And I think the next one I had a question on was number 10. Oh, I remember doing this one.
If I need help with that one.
Yeah, I was like, ugh. It's kind of ugly. Not going to lie.
It's a little odd.
Yeah. Yeah. Click back over real quick and double check writing it down. Sometimes I don't trust myself to actually write the problem down right on my work. Square root of 10 times the cubed root of 10, all raised to the 8th power, equals. And then I would change these to rational exponents. And remember, the denominator is what is in the little root thingy. And when there's nothing in the root, in the little check mark of the radicand, it's an assumed square root. So you can do a number of things here. You could actually, if you wanted to, go ahead and distribute your 8 to both of the things inside the parentheses if you wanted to, or you could actually add the 2 things in the parentheses and then distribute the 8. Either way, just because when I look at 8 and 1/2, I'm like, oh, that's going to give me a pretty number. I think I automatically do that. So I would distribute this to be like this, 10 to the 4th, because that just turns out pretty. But I still kind of have something ugly here. So I think either way, you're going to end up where you have to have a common denominator in order to combine those. Or I don't want to make it too confusing on you guys. So I would just do this. Oh, what did I do that for? Never mind. I did that so my denominator would be easier. And then I didn't. So that's going to give me 20. That's 10 raised to 20 over 3. Which is the cube root of 10 to the 20th, which how many of those can you take out? You can take out 6, right? And what would be left in there? 2. So you could leave it like that, or and I don't. And if you can write out 10 to the 6th and put all your zeros there if you want to. Three, 4, 5, 6. And that's your final answer. And it is ugly.
Can you just leave it as
Can you leave it as what?
10 to the 6?
Oh, yeah. Instead of writing that out?
Yeah.
Oh, absolutely.
Okay.
And I mean, even if you wanted to leave it like that, I would be fine with that. I wouldn't put the dot in the middle. I would just do this.
Okay.
Or even 10 squared. Okay.
Okay. Thank you.
Uh-huh.
I'm almost done
Is
writing.
Oh, okay. No problem. I'm looking back to my reference sheet. When I get the emails, I like to write them down in one place so I can see what I'm doing, what I need to work on next. The next one that I got a question about was number 11. So that'll be the one that Jake, I'm going to start erasing more toward the top if that's okay.
Go ahead. Oh yeah, I got it all written down.
Okay. I appreciate when you all, let me know, so.
Mm-hmm.
We're getting some whopper answers for some of these. I'm like, wow.
Mm-hmm.
Number 11. Trying to map out my space because I use a lot of paper when I do these. And I don't, x to the 6th, y to the 4th. And y'all catch me if I write anything down wrong because sometimes I don't transpose my own writing really well, embarrassingly as that is.
It's all right.
X to the 1/3, y to the 1/4, and that's all squared. Okay, so what I would do for this one to simplify is to go ahead and multiply my exponents times, because this is a power to the power. And so this one would be x to the 6/8, which that really reduces, and this is y to the 4/8, but I'll do that in the next step just so that y'all can see. And then 2 times x to the 2/3 times y to the 2/4.
And you're adding
This
those,
would,
right?
I'm sorry?
You're adding those two. Like the first
2 in the middle. Yes. So this then goes down to 3/4. This goes down to 1/2 times 2x to the 2/3, y to the 1/2. So I'm adding 3/4 and 2/3. Oh, I'm adding. I see what you're saying. Duh. And I had multiplied. Bless your heart. Thank you, Rachel.
I was wondering why you put that there.
Yes. Sorry, guys. Sorry. All right. Since I'm adding, that's as far as I can go. Believe it or not, that's it. So your final answer is, I'm telling you, I can't read my own writing. I need to just go from the book. This is as far as you can go because, and the one thing that's throwing us off, and probably why they put this in here, is because these two little things right here are different. So you cannot combine them. Even though our y exponents are the same, the x exponents are not. So they cannot be combined. So this is your final answer.
Okay, so you're not allowed to write it down anymore?
Nope, that's it. Because of that plus sign that you caught me on.
Okay.
Does that make sense to everyone? Any questions about number 11?
Okay, I'm good on that one.
Okay. The next one I have written down is number 12. Because that was 11, right?
Yes, this is 12 now.
Okay. Y'all watch me on writing them and make sure I get it right. So I can add the top because they're alike. Multiple ways to do this, and I'm trying to think of the least.
I thought it was completely solved right there.
No, sir, because you have to rationalize the denominator. You have to multiply the top and the bottom to get that 7 out.
Are you allowed to go ahead and take out 2 sevens right now from the denominator?
You know what? I think that that's what I would personally do. So let's get it to there. Let's do that. Let's do 7 times 7 cubed all over, and then we could take 2 sevens. We could take 7 squared out, right? We got 7 times 7 times 7 times 7 times 7. So we could take 1. So we can take up 49 out, right?
Right.
7 squared. And that would leave us the square root of 7 in there.
And so then you need to multiply the top and the bottom by 7 for the root of 7.
Yes.
Okay.
I'm just rewriting this down here. I just rewrote that, what was at the top. So that's going to be 7 to the 4th over 49 times 7, right?
Right.
We got 7 to the 4th, so that's going to come out and be 7 cubed on the top, which is really the same as 49 times 7, because that's the same as 7 cubed, so the whole answer is 1. So yes, you can do it.
Oh, I actually got that answer.
Did you?
I did.
Yay!
Yay. Okay, thank you.
No problem. It started really ugly, didn't it? To look at the original problem and to think that original problem, the answer is 1. Those are the things in math that make me laugh. I'm sure they don't, y'all. I've got that strange, geeky kind of sense of humor, I realize. But I look back at that original equation and I think, oh, sweet Jesus, the answer to that is 1. Did y'all get that written down? And does anybody have any questions on that? Once again, there were multiple ways to look at that. You could turn those into fractions and all kinds of stuff. So there's lots of ways to look at doing these problems as long as you stay within the boundaries of exponent and radical rules. You could do it differently, because I know the worked out solution that I definitely would have done it more like this. I don't think I did on my paper. I think I moved it to fractions for some reason, but I did get the same answer. But even the back of the book did it differently than we did just now, or like the worked out solutions that are included with this lesson were a little different, but all the answers are 1. That was number 12.
Yeah.
Okay. Now number 13. The original equation. Did Miss Wynn assign y'all number 15?
Yeah.
Okay. I didn't assign my kids 15, but I will absolutely work it with you. But Miss Wynn loving geometry the way she does, I know why she did it. Did I write this down right?
I think so, yeah.
Okay. I didn't write a plus for a times or anything like that this time. Okay, good. All right. So at the top, our radicands are the same. They're both square roots. So I can combine what is in them. So I'm going to make that a 2x to the 4th over 64 x to the 15th square root. So I'm kind of with you, Rachel. I'm going to actually pull out everything that I can.
Okay.
2x squared. And then I can pull out an 8 and an x to the 7th, but that leaves a square root of x in there. Is that how you understand it as well?
Yeah, that's how I did it.
Okay. So I have to.
Wait, where did you get x?
X to the 15th. If I take the square root of x to the 15th, I get 7.
Okay.
Okay.
Yes, that makes sense.
Okay. All right. Thank you for stopping me when you have a question. You guys always do that, please. As pretty as that is, we have to make it a little ugly first because we have to rationalize that denominator. And to rationalize that denominator, we're going to multiply the top and the bottom by the square root of x. So that's going to be 2x squared times the square root of x. And then this, when we multiply this x times the x, that's going to be an x squared. So I'm just going to add one more x to my 7. And now I've got to combine this one with this one. And I want to also divide my 2 and my 8.
You're allowed to do that?
Yes, ma'am.
Okay.
So 2 minus 8, that's going to give me a -6. So I've got a root and I've got a 1 left on top. And I've got a root x on top. And on the bottom, I have an x to the 6th.
Okay. So
that's my final answer.
We weren't allowed to combine the x's together.
We actually have been doing that along the way. They've just been fractions, some of them.
Oh, okay.
But we actually have been doing that a little bit along the way. I'm trying to think.
Number 11. We weren't allowed to combine. We were left with x to 3/4, y to the 1/2 plus 2.
Oh, I see what you're saying. I see exactly what you're saying. All right, I'm going to go ahead and write the answer to number 11 down right next to this. I do not want to confuse anybody, but this is what, number 13, correct? Is that the one we're on now?
Yes.
Okay, and this was the answer to 11, and it looked like this. When you're multiplying or dividing, you can combine x's and all of that other stuff. When you're adding or subtracting, you cannot. Does that make sense? Like everything has to be uniform when you're adding and subtracting. Here, when you're multiplying and dividing, you kind of do the combination. That's why it was so crucial that you caught my error of writing a multiplication in that number 11. Remember early on, you said you're adding, Miss Sparks? And because I originally had written it like that, you would have handled the problem completely different, because then you would have combined your x's.
Okay. That makes sense.
That changes the rules completely. And that was a great question, and I hope that made some clarifications for everybody. But that was really a good question for clarification. But number 13, that's your answer.
Okay. Thank you.
Uh-huh. And then let's see, I have number 14 and 15.
Yeah.
That I was emailed about, so I'm going to work on those as well. I wish Miss Wynn was here to enjoy 15 with us. Her sweet little geometry self. And y'all, I am not going to redraw that diagram. You should see it on my paper. Not pretty. Not pretty at all. Number 14. And once again, y'all watch Miss Sparks and make sure that she writes the problem down right. Y squared times the 5th root of 64x to the 6th minus 6 times the 5th root of 2x to the 6th y to the 10th. Did I write it right? Is that everything? Okay, let's break this down, and I'm going to go ahead and factor what's inside of each of these first. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. X to the 6th minus 6 5th root 2 x to the 6th y to the 10th. Okay, 1, 2, 3, 4, 5. So I can take 1, 2 out because I got to pull out in sets of 5. So 2 y, actually I'm going to leave a little space. Y squared. And then 5 goes into 6 one time, so I can pull an x out. So what do I have left? I have a 2 left, and I have 1x left. So I'm going to write that down. Minus 6, and then the 5th root, I've got a 2, and 5 goes into 6 one time with 1 left over. So I've got an x inside. 5 goes into 10 2 times with nothing left over. So now let's take a look. We've got the 5th root of 2x times the 5th root of 2x. So, and our 2xy squared 5th root of 2x, and then xy squared 5th root of 2x. So these coefficients can actually be combined. So 2 minus 6 is negative 4x y squared fifth root of 2x. And that is your final answer. Can I erase this?
Yes.
Okay. Did that make sense to everyone?
Yes, it did.
Any questions about that? Okay. And if I have any of my students in here, y'all will really appreciate this next one. Number 15. And what a beautiful note to end Math Lab on. Let's take a look at it after I get this erased, because I'm just going to tell you this one does take a page. Just FYI. Okay, find a radical expression for the perimeter of the red triangle inscribed in the square shown to the right. Okay. So once again, I'm not going to try to redraw that. My drawing would not be pretty. But so basically, what you're going to have to do is find the side lengths of each one of the sides. And when it's inscribed in there, what I want you to note is that each one of the external triangles around it are all right triangles in some way. And I'm going to try to describe this as best I can because I can't really draw on this page. The upper left-hand corner is a right triangle. And this is a square, so that kind of helps us know all those side lengths. So every side length is 8, but they did give us a hint on the upper right-hand corner that piece, that one little side piece is 2 and 4, and the lower right-hand is 4 and 8. So, so that will help us to be able to find each one. And kind of the only thing that, if you all will, the upper left-hand corner, I'm going to call that right triangle A. The lower, okay, so the upper left is A, the lower right is B, and the upper right is C. And that, but y'all, the reason why I have to distinguish that is to be able to give all the different sides their proper name. Okay, so by that I mean, okay, so for the upper left triangle, it's a upper left right triangle. I'm going to call that A. And with a right triangle, we have the good old Pythagorean theorem. Yay! Oh, how we've missed it. You would have, for one side length, you're going to have 8 minus 2 because the square itself, I can draw the square. I can't even draw the square really because that's a rectangle. But basically, we know every side is 8. I said I wasn't going to draw it. Oh, my drawings are so bad. That's supposed to be a 2 and a 4. And that's a 4. Okay. So we've got 8 minus 2 squared plus 8 squared equals c squared. Because this line right here is going to be my c. Okay? So that's 6 squared plus 8 squared equals c squared. So 36 plus 64. And thank you, Lord Jesus. It's a beautiful thing. So 10 equals C. So one of the sides is pretty. All right. For the lower right, which I've got 4 squared.
Is that B that's
Plus,
next?
yeah, I'm sorry. I've said I was going to name them. Okay. 4 squared plus 8 squared equals C squared. So that's 16 plus 36 equals C squared. Did I do that right? No. Oops, no, I didn't. 64, Miss Sparks. So that's 80 equals C squared. And then if I factor 80, let's see, that's 16 times 5. So that gives me 4 times root 5 equals C. So another one of my side links is that. Okay. Which one am I working on now? I'm working on the very last one, right?
Mm-hmm.
Okay, so that's going to be the upper right. Is that right?
I guess so.
Okay, so the upper right triangle. Which I think I labeled as C, is going to be 2 squared plus 4 squared equals C squared. So that's 4 plus 16 equals C squared. And then that's 20 equals C squared. So that's going to be 4 times 5 C squared. I forgot to do that here so that y'all could follow my steps. I'm sorry. So that's 2 times root 5 equals C. So plus, so I'm going to rewrite that. I didn't give myself room. So we had 10 as our first answer, and then 4 plus root 5 as our second answer, and 2 times root 5 our third answer. And we're trying to find the perimeter. So we're going to combine like terms, which the only like terms we have are the ones with the root 5. So that is your final answer.
What's my final answer?
10 plus 6 times root 5.
Okay.
And this is right here, right there. This is where I took the side length of each one and then added them together.
Thanks so much for your help.
Oh, no problem. Thanks for coming to Math Lab.
Bye.
Bye-bye. Have a great day.